At room temperature, the following reaction goes to completion. 2AB plus B2 forms 2AB2. AB2 is solid with negligible vapor pressure below 0 degrees Celsius. At 300 Kelvin, the AB in the smaller flask exerts a pressure of 3 atm and the larger flask exerts a pressure of 1 atm at 400 Kelvin when they are separated out by a closed valve. The gases are mixed by opening the stopcock, and after the end of the reaction, the flask is cooled to 250 Kelvin. So now we have to calculate the total pressure thereafter. So first of all, let's calculate the number of moles of AB present. Okay, this will be given by PV divided by RT. So the pressure in that flask is given to be 3 atm into the volume of the flask is 8.21 liters divided by 0.082 into the temperature of the flask is 300. So the number of moles of the first one come out to be 1. And the number of moles of B2 similarly will be 1 into 8.21 liters divided by 0.082 into 400, and this comes out to be 0.25. Okay, we have the moles of both the components. Now let's look at the reaction. The reaction is basically 2AB plus B2 forms 2AB2, right? So initially we have 1 mole of AB and 0.25 moles of AB2. For 2 moles of AB, we require 1 mole of B2. So for 1 mole of AB, we would require 0.5 moles of B2. But we do not have them. It would mean that the limiting reagent is actually B2. So 0.25 moles of B2 will be consumed. Okay. And corresponding to that, 0.5 moles of AB will be consumed. That is twice the moles of B2 consumed. So the moles of AB left will be 0.5 moles and the moles of AB2 formed will also be 0.5 moles. Okay, and there will be no B2 left. So now let's look at what all we have in our reaction. We have 0.5 moles of AB after completion of the reaction, 0.5 moles of AB2. Okay, and now the final temperature is going to be 250 Kelvin. Now 250 Kelvin is less than the room temperature. It would mean that AB2 would solidify and so would not contribute towards the pressure. So what we have is the volume equal to 2 times 8.21. The pressure is something which we have to find. The number of moles is this. And the temperature is 250 Kelvin. So let's just apply the ideal gas equation. P will be equal to nRT divided by V. N is 0.5, R is 0.082, T is 250 divided by V is 2 into 8.21, right? So when we solve this, let's just do this here. We get 100 over here. This gets cancelled out and this gets cancelled out, and we are basically left with 2.5 divided by 4, and this would give us a pressure equal to 0.625 atm, right? So our answer to this question becomes option